Hi, and welcome to our 119th test and measurement video. Today we'll discuss a potential hazard in using the conventional grounded bench type oscilloscope. By way of background, consider the electrical service circuitry where power is supplied by an aerial or underground utility-owned distribution system. It doesn't matter whether it is single-phase or three-phase, nor its voltage. For simplicity, we'll examine the single-phase 120-240 volt system. The transformer secondary winding supplies two voltages, 240 volts at the endpoints of the windings and 120 volts between the endpoints and the center tap, which is grounded. It is a three-wire, two-voltage system. The three conductors come into the building and terminate in the entrance panel, commonly called the box, where the center tap-derived neutral is once again, and for the final time, grounded. Then the neutral, white, and one of the hot legs, solid color other than white or green, is brought to the point of use. There is another wire, green or bare, that is grounded at the entrance panel. Electrically, it is the same as the neutral, but it serves a different purpose. In the building, the hot, neutral, and equipment grounding conductors comprise the branch circuit, and they go in a single jacket or raceway to the receptacle, typically in a wall-mounted plastic or metal box. The oscilloscope, like various tools and lamps, plugs into this receptacle, and the cord enters the oscilloscope. Regardless of whether the power is on at the entrance panel, and regardless of whether the oscilloscope is turned on, all normally non-current carrying parts of the oscilloscope, including metal chassis and metal enclosure, if any, are directly connected back through the branch circuit to the entrance panel neutral bar, and ultimately to the center tap of the transformer secondary. Everything is grounded, and therefore it is not hazardous to touch the non-current carrying parts. Modern oscilloscopes have insulated plastic enclosures, but there are inevitably some exposed metal parts on the outside, notably the metal connectors at each channel input. As it happens, when you plug a probe into one of these, the equipment grounding conductor becomes connected to the probe ground return lead. And if you connect the ground return lead to a wire or terminal that is at some voltage potential that is referenced to, but floats above ground potential, there will be a sudden flow of fault current with possible damage to the equipment under investigation, the oscilloscope, and the technician. It is to be emphasized that it doesn't matter whether the oscilloscope is powered on. As long as it is plugged into the receptacle, this potential hazard exists. There is no problem in connecting the probe tip to this floating voltage. Here's the probe tip. And this is the ground return lead. The hazard arises from the ground return lead connection. Some folks get around this problem by sawing off the ground pin in the oscilloscope plug. And it is true that this eliminates the hazard that we have discussed. But besides being an electrical code violation, this expedient introduces a different, perhaps more dangerous hazard, which is that in case of ground fault within the instrument, the normally non-current carrying metal parts become energized to the full secondary voltage, thereby becoming a shock hazard. The floating voltage hazard can be mitigated by use of a differential probe, but it is quite expensive and it reduces the bandwidth of signals that pass through it. Notice that in this variable frequency drive schematic, the two capacitors form a voltage divider on either side of the ground connection, and both sides are therefore referenced to, but float above, ground potential from the three-phase input to the final output at the motor. Most technicians in working on this type of equipment make use of a handheld battery-powered oscilloscope with all inputs insulated from one another and from ground. This is safe as long as all inputs are rated for the voltages involved. Thanks for watching. New videos are added periodically, so check back frequently.